he's just going to be helping us out technically. We're from team 1014, Bad Robots, and we thought we'd go through some command-based robot structure with you guys today. So to understand command-based structure, you kind of have to know what came before it and what the alternatives are. Besides command-based robot structure, you can use simple robot, and simple robot structure is the simplest of them. There's essentially one class with two methods, autonomous control and teleop control. They are heavy on loops because they're not called periodically. So as soon as teleop starts, it calls that method, and then you have a while loop in it that says while is enabled, run the code. Same goes for autonomous mode. Iterative robot then takes it a step forward, and it uses periodic functions. And what that means is that while in teleop mode, the program calls teleop periodic multiple times, calls it many times a second, and updates the robot that way so that the programmer doesn't actually have to code any loops in there unless there's some kind of thing that it needs to loop through for briefly. Both these classes extend robot base. And robot base is important. That's the entry point of the application of the robot program. So as soon as the robot boots up and is all ready to start running, it calls robot base, the main class, and actually starts, and that's where all the other code of your program is called from. So robot base is really where the program starts. It's a real important class.
All right, next, here's the flowchart for the command structure. What we have here is, it starts from the command-based robot. So this is the version, and the first class we're going to talk about is the main class. Basically, this is the jumping off point that John just talked about with the iterative robot. So everything starts from there. And what's inside is an example.
Yeah.
Oops. An example
First tab.
is right here. So, alright. So this is on our GitHub. This is open source. Here's all the code. So the robot main basically we use smart dashboard. So then we have assemble chooser, allows you to choose the command you want to run, and the init, the autonomous init. So we can choose between autonomous or teleop. And this is just
When are robot init and autonomous init called?
right at the beginning of the program.
Okay, cool.
So it's just like the periodic calls. It will just automatically run through, run the init first, run the periodic.
After that point, while it's enabled.
Exactly. Next, we have the OI. The OI basically just takes in the controller inputs, user inputs, such as the joystick command. We're using Xbox, so it's taking like the right joystick, left joystick, the buttons, and the triggers, and it'll just map out all the buttons. And what we do is dead zone our numbers.
Just hit Safari and it'll open it up.
Alright, so what we have here is our joysticks, and then primary joysticks, buttons, and then it just maps out for what we have. And what we have is getters, but we dead zone them, meaning that even if it's like right when it's set up, if it's like little moved off of like the base 0, 0, it won't do anything like drive the robot.
So if you have an Xbox joystick that you've used a lot and it's a little loose, the joysticks are a little loose, it'll zero those when it's just like a very small offset of the origin of that axis. And that way you're not running motors with real low voltage when they're not really running, but you're giving them voltage.
Yep.
Again, all this code is available on our GitHub repo. It's open source. You can find our organization. It's called Bad Robots, plural, 1014. And we have quite a few repos with a lot of code in there. You can just check that out.
Next, we have the robot map. This is another class there. What it does is it relates the hardware to the software. So all the hardware, such as Victors, speed controllers, motors, all mapped out there so that we can reference them in the UI and commands to use.
It's really just an organizational class. It's not essential, but it helps a lot when you're debugging. And you'll see. So we have all these static variables.
We have touch controllers, ultrasonic, and then what we have here is organization between prototype and final map. So there's like 2 different robots and these are the motors. And then we also have the IP addresses for the cameras.
So then these things are all referenced outside of this class. When you, like for instance, when you want to initialize a Victor, you say new Victor and then you feed it bad robot map dot whatever the variable is.
Yeah, because these are all public variables, so you just automatically call them. So all of these are organized within our class right here. So each of them are just classes right here. But then next we have subsystems and command inside. Subsystems, for example, is a drivetrain. Basically, it just groups multiple hardwares together to create a subsystem that we need for the competition, such as a drivetrain to move forward and around. It controls 4 motors that will drive the robot. An example.
Well, let's wait till we get to the subsystem slide. So we'll go in depth in a
We'll go in
future
depth.
one. Let's just go over commands real quick.
Yeah, in commands, basically it's the smart. It just controls the subsystems and has methods that such as drive forward. We'll go in depth later, but this is just a brief overview of what command-based robot is. And you can